Hi, my name is Mia Wood, host of the Lab Roots podcast, The Life of Her Mind. Lab Roots is celebrating International Day of Women and Girls in Science on February 11th with a giveaway. We're giving away four $25 gift cards to the Lab Roots Science Store, and entering is easy. Just check the episode description for the entry form and details. Be sure to enter by 5 p.m. Pacific on February 11th. Meanwhile, a huge thanks to the women pushing STEM forward every day, and good luck to everyone who enters. All right. Well, so hello and welcome to Lab Roots, The Life of Her Mind, a podcast devoted to how women think about their lives, professions, careers, and futures. My name is Mia Wood, and I am delighted to be in conversation today with Dr. Jeanne Jordan, whose extensive career most recently includes serving as director of the International Institute for Public Health Laboratory Management. Dr. Jordan is also an emeritus professor at George Washington University. Welcome, Dr. Jordan, and thank you for taking time to chat today.
Oh, thank you, Mia. It is an honor and a privilege.
Oh, thank you so much. Well, let's get started. So, you have accomplished so much. It's hard to know where to begin. So, maybe we can start chronologically. How did you come to study science in the first place and then conduct research in microbiology, clinical laboratory medicine, and virology?
Thank you for the question. Well, I have to say that from very early on, as a young child, I was extremely curious, loved to ask questions, wanted to know how things worked, and was keenly aware of viruses from early on because I grew up in the 1950s during the polio epidemic. And so it was that time where you first had a black and white television set in your living room and you were watching young kids in iron lungs who had paralytic polio. You then had, your neighborhood pools closing down. And so there was this fear in the neighborhood of catching this disease. And I can remember standing in line at the Dane County Agricultural Building as a little kid with this long line of people outside waiting for their first polio vaccine. And so that was very memorable for me. And to make a sort of 360 on this, that polio vaccine that I received ended up being the senior scientist who developed the Salk vaccine was my PhD mentor, Dr. Julius Youngner. So that was a full circle moment in grad school thinking about that.
Can I ask real quick, what was he being um, at the university, why you went to grad school in at Pitt, right?
I went to grad school at Pitt,
Yeah.
um, and I chose him for my mentor. But at the time, it was for sort of other reasons in terms of what he was studying, because he wasn't studying poliovirus then.
Okay.
But yeah, to be able to then sit and hear some of his stories
Mm.
were just amazing. Like he, at one point in late in his career, said to me, my first job was to develop something that killed people because he was part of the Manhattan Project in Oakwood, Tennessee, studying the effect of uranium salts on skin and lung tissue. And he had no idea what it was about because nobody knew what they were working on, right?
Mm.
They didn't know they were working on the atomic bomb.
Mhm, mhm.
And he said he then finished his career having developed several different vaccines that helped save lives. So that was really impactful, right? So, um, so in addition to sort of growing up in the era of polio virus, the other sort of awareness I had around viruses was the fact that my dad told me a story when he was growing up on the farm. They had poultry flocks, and their entire flock was devastated by Newcastle disease virus. So it's a very highly infectious virus for chickens.
Mm-hmm.
And once that gets into your flock, you have to literally cull the flock in order to then start again. So those were sort of two big things as a young kid in my childhood that made me aware of infectious diseases, I guess. And yeah.
And so, as you embarked on your undergraduate career, you were thinking already in terms of infectious disease, well, science very generally, but then more specifically, infectious diseases.
Yeah, I have to shout out to my eighth grade biology teacher, Mr. Ravenhorse, who made me totally fall in love with science. I mean, everything he did was so much fun. And it was then taking as many science classes in high school as possible and realizing that I wanted to go into science,
Mhm.
but saying to myself, all right, if I go into science, what field can I go into that will allow me to get a job after I
Mm.
graduate, right?
Mhm.
So I ended up selecting medical technology, which then gave me a great opportunity to have a job right out of college. But while I was in college, my first lab job that I ever got was at the Food Research Institute at University of Wisconsin-Madison,
Mhm.
and they were studying foodborne diseases and specifically toxins that are secreted from both Staph aureus and Bacillus cereus as two sort of foodborne agents. And I got hired initially as the dishwasher for the lab. It's like you have no experience, you go wash the dishes. But eventually, with persistence, they've let me sort of start helping with some of the experiments. And I got to work with animal models and do quantitative culturing of bacteria out of foods that we were studying. So that was fun. And then when I graduated with my medical technology degree, I got the opportunity to get a job at the University of Wisconsin-Madison at the hospital, at the University Hospital in the microbiology lab. And I learned so much because it was a critical care hospital, so much about bacteriology and parasitology, and did that for several years and really sort of um, appreciated the importance of how the lab generated
Mm.
results that
Mhm.
could impact individuals' health,
Mhm.
right? Um, and then went on for my first research job after that, where virology was the focus of the research. And they hired me knowing that I had no virology experience, but he sent me to CDC for a 2-week course on how to prepare tissue culture, how to infect cultures with viruses, how to harvest those viruses. And it was that opportunity to go to CDC and learn those skills and then apply them to design an assay to measure IgG and IgM in spinal fluid
Mm.
for individuals that they were trying to diagnose or rule out herpes encephalitis, which at the time, the only assay they had was to do a brain biopsy,
Mm.
look for viral inclusions in that particular tissue. So we generated this assay, we validated it, and it was my first opportunity to put a publication together. And so it was between sort of working with virus and having this publication that it was like, yes, I want to study viruses.
Okay. Yeah.
So
Excuse me. So when you mentioned earlier, so you've got this fascination um, with, for lack of a better word, at least from our standpoint, nature gone wrong, right? So polio and infected flocks
Newcastle
of
disease
birds.
virus, yeah.
Yeah. So you've got this interest. It sounds also like you were certainly encouraged to pursue it from a number of people in your life, but then you also took a practical standpoint when you said, okay, well, what am I going to do for a job? And you went into medical technology. Now it sounds like when you got out of the initial training that you received out of the CDC, that you are now in a position at this stage in your career, or pretty early on, to combine the two. Is
Mhm.
that fair?
Yes, absolutely.
Okay.
Yeah.
So what did get you into medical technology? Like what made you say, yes, this is a field that I can find secure work, in which I can find secure work?
Yeah. I mean, the topics were incredibly interesting,
Mm,
you know, because as a medical technologist, you're trained not just for clinical microbiology, but all aspects of sort of human health,
mhm,
hematology, chemistry, blood banking, everything. And so
mhm,
you get this incredible hands-on, not only book knowledge, but you're rotating through all these clinical
mhm,
labs as part of your internship, your last year. And so, you know, there was also a part of me that said, I need to be able to get a job that will have a decent salary and where I can be financially independent after having graduated from college. So that was really important. I was the first person in my entire family to go to college. So um, I and as a sort of woman growing up in the 60s and 70s, it's like, that movement of,
mhm,
feminism and independence. And it
mhm.
was like, yeah, that is my goal, is to be able to know that no matter where I am in life, I can have a job, have skills, and, you know, be agentic, I guess. Is that the
Mhm.
right word? To have agency.
Right, right.
Yeah.
Yeah, to be able to take care of yourself and to make your own choices, which even at that time were still, you know,
Oh, yeah.
fairly limited, if we can say. I often will say to class members and where uh, I'll say, everyone, because they're, anywhere from 18 to 22 years old, typically, right? So, I was born before it was. At the federal level, legal for a woman to have a credit card in her own name, to get credit in her own name, and I say, and I'm old, but I'm not that old. So it's, or I might say something like, look, you were born before the first Black female Supreme Court justice was appointed. Think about what that means in terms of your life. So, yeah, so it makes sense that you're thinking both in terms of what you're really interested in pursuing, but also that you want to be self-sufficient. Yeah.
Yeah. I
Um,
can remember walking into my first study section at NIH when they were all in person
mm,
in Bethesda, sitting down at the table and looking around and saying, there is not another woman sitting at this table as a peer reviewer. And I was like, holy heck. Yeah.
and so yeah, so okay, so you're aware of it, you're taken aback. Did it affect you in any way? Did it not have an influence on how you moved forward in that work and in your career?
Oh, you always showed up to the table fully prepared because how you were judged was different than how a man was judged,
Mm-hmm.
right?
Mm-hmm.
So you wanted to make sure that your word was believable or that they would be willing to consider your opinion. Yeah.
Okay. Yeah, so that you had to be authoritative in a way that your male counterparts didn't have to work so hard to be viewed as such. Okay.
Yeah, and as an introvert, that's hard to do.
Right. Yeah, to assert your place at the table, right.
Yes.
But now, if I may, fast forward, you're the director of the International Institute for Public Health Laboratory Management. So what is that and how and why did you become involved?
Oh, this was such an amazing opportunity. So I'll step back and say I remember sitting in my lab at University of Pittsburgh, and the phone rang, and there was someone on the other end that I had no idea who he was. It was a cold call from my former chair, Dr. Alan Greenberg. And he said, I just talked to a friend of yours at Emory University who said you might be willing to relocate. And we're looking to hire our first laboratory scientist for the School of Public Health at George Washington University. And one of the things that he talked about as an opportunity was this involvement in global public health projects.
Hmm. Hmm.
So the International Institute for Public Health Lab Management was a collaboration between APHL, which is an NGO in DC called the Association for Public Health Labs. So this collaboration between APHL and GW. And the goal was to sort of form this collaboration where the goal was to create a space where international public health lab professionals, so senior lab professionals, could come together and participate in this 2-week course that we had created or that we were creating at the time that would focus on lab strengthening. So APHL got a lot of their funding through CDC. And at that point, CDC was funding this global effort, not only sort of nationally, but internationally, to strengthen public health labs. And so we built curriculum for this and developed this international public health that focused on international public health priorities. And the first few years, we actually had this course at GW in DC. And so everyone came from many countries in sub-Saharan Africa. That was kind of the focus of where we were pulling public health lab professionals from. And eventually it was like, shouldn't we take this there so that more individuals can sort of locally make their way from one country to another in sub-Saharan Africa as opposed to having to come all the way across the Atlantic to DC. And so that's what we did. And we built this course, and there were Ralph Temperi, who at the time was the director of the global arm of APHL, and now Lucy Mariogo Robinson, who's now the director from APHL. I worked with them, and then other faculty from GW, like Dr. Dante Verme. He taught GIS, which is this geographical sort of information systems. And I focused on lab testing and sort of cutting edge lab testing that I could introduce to them, as well as some point of care testing that would be great for sort of resource limited settings.
So so the GIS piece just threw me because I'm thinking, okay, how did you all how did you fold the two together? And probably when you tell me, I'll say, oh yeah, okay, that's obvious, but I didn't think of it on my own. So it couldn't have been that obvious, at least to me. But so how did you fold the two together?
Well, so he taught the practical application of using the software, sort of asking the question, entering the surveillance data, and then being able to have these physical maps to kind of show what the trends looked like, And so it was, basically it would be that sort of conveyor belt of samples coming in, testing being done, the data given to the GIS folks who could then help answer the question around surveillance and trends, where you could be then making policies to help mitigate infectious disease. And
Oh, that's a fascinating combination.
yeah,
Thank you. Thank you for that.
sure.
And that also that so the initial setup, the initial direction, and then the thinking, hey, we really need to go to the sources, leads me to a question about global public health. So, if we didn't know it before, those of us who are not steeped in public health, let alone global public health, we certainly experienced firsthand during COVID, right? That there are, local impacts of global health issues. So how do you and your colleagues explain to non-experts the significance of the work that you do, let's say in from the standpoint of, someone in the United States, a far-flung locale, right? That what happens there really is important, if not by itself, it is important to us locally.
Yeah, great question. If you think about it, a disease is just one plane ride away,
Mhm,
right? I
mhm,
mean, if it's someone gets off an international flight at Dulles that came in from somewhere else in the world and got was incubating an infection. So it's funny because during the pandemic, my aunt said to me, Jeanne, I don't think before the pandemic anybody even knew what a virologist was.
mhm,
and so it was really a great time to sort of take the opportunity if people asked to answer their questions, especially if they were curious and wanted to know.
mhm.
It was a great time. It was a teaching moment to kind of
Mm,
talk about what what we do in the lab and the importance of having those results and how that can impact sort of transmission of infections and the idea of knowing that we are such a connected world with airplane travel that a problem somewhere else can be your problem tomorrow.
mhm,
And in fact, not to get off this topic too much, but just before the pandemic, for 2 years, I volunteered at the Smithsonian Museum for their outbreak exhibit.
oh,
And it was this amazing exhibit they put together that stemmed from, smallpox and influenza and Ebola and, SARS and MERS and HIV, etc. And it was so much fun to have the public coming into that space,
mhm,
from adults from all over the world to school to classes who came in for school trips, and to talk to them about all this stuff and to communicate science to the general public. That's where I really appreciated sort of how you can really raise awareness in
mhm,
the general public
mhm.
in that way. And then, ironically enough, it all closed down when the pandemic came. And now they've taken it apart. I'm sure nobody wants to talk about outbreak
Oh,
exhibits.
right. But so you've raised a really interesting point, and thank you for sharing the Smithsonian public education um, piece of your work for a couple of reasons. One is, I mean, I know that you educate scientists, right? So you're a professor, but and I'm reminded of a conversation I had with a scientist, Dr. Kelly Smith at Johns Hopkins, namely about the importance in your capacity as a scientist to educate non-scientists, to educate the public so that we all have at least the opportunity for a solid understanding of what it is that we're dealing with in at once a very complex but still small now global environment. So you really enjoy that sort of public outreach?
Oh
Yes.
gosh,
Yeah.
yeah. I just having that chance, especially with young kids, to
Ah.
talk about this stuff. And the Smithsonian had so many cool exhibits at eye level for younger children.
Mm.
One was this uh, animal exhibit of what a wet um, market looked like, and with civet cats and their sort of role in spreading viruses and bats and various things. So yes, I and now that I have a very young grandson, the idea of being able to teach young kids about this. So when I went to Falk School
Mhm.
and got to see the sixth graders and eighth graders in the various science classes last week, it just melted my heart because they were so excited to like hear from you and ask you questions. And it's like, that's the kind of curiosity we need.
Yeah. And they ask great questions too, right? I
They
mean,
do.
what's a question that kind of made you go, "Oh, how fun is this to think about?" Or this is an interesting question.
So one of the questions they asked was, all right, so are viruses living, And I was like, oh my gosh. So we got into the whole idea of no, they need, cells, be it animal or human or whatever. They need a living cell in order to sort of take over the chemistry
Mm.
of the cell in order to make more of themselves. So I said to them, no, I don't believe viruses are living.
Interesting, interesting. Okay, so there's so the kids are asking really interesting questions and they're excited to learn. Do you find, so I know there's a jump between sixth and eighth grade and, high school and then college and graduate school, but do you find opportunities with older students for the sort of mentoring that you found so rewarding, particularly kind of coming back, like you said, full circle to Dr. Youngner,
Yeah.
having done all that amazingly groundbreaking work on polio vaccines. Do you find it as exciting to mentor young scientists?
Oh, I love to mentor scientists. And in fact, I'm mentoring three right now who went through the Masters of Public Health and Public Health Microbiology, Emerging Infectious Disease Masters at GW that I taught during their 2 years there. And now they're doing their final projects.
Mhm.
And I said, oh, I'm happy to continue to mentor them. But yeah, it's such a gift to be able to give back
Mhm.
and to know that you may have a few pearls of wisdom to sort of share with them that you did not perhaps have when you were at that sort of stage of your career.
Mhm.
And so anytime I can help others, I'm it makes my day.
Is that, well, so my last question is kind of unfair to you, given what you've just said, but is that, or is there another part of just science full stop, that's the most exciting to you? Like what really gets you going when you're in professional mode?
Yeah. So for me, it's this sort of longitudinal, this progression that if you've been in it long enough, you can step back, reflect, and see. And that is sort of starting out with first asking the question, what question do you want to ask? Is it biologically relevant?
Mhm.
Um, is it an important enough question to raise and to work on. And then if you're lucky enough through this sort of peer review grant funding, if you end up at the end of this having data that makes a difference and that you've discovered something, right? The ability to then publish that, to share with others, so that with each little increment, with each little step, you're able to add to scientific knowledge that others can then use to then move forward on their own. And then with these discoveries, sometimes there comes an opportunity to invent something, right? So for me, it was always sort of creating new molecular diagnostic tests. And, you know, during the COVID pandemic, we got the opportunity to work with a professor in engineering in our building at GW, and they had a microfluidic device that we then built a SARS-CoV-2 assay on, right? And so that was something that was then sort of purchased by a company, and then just to sort of step back and say, did my research actually impact the lives of others? And if I can share a story with you, the
Please.
first time that I saw this, which just blew me away, my first molecular diagnostic test that we decided to put together, design, implement, validate, all of that, was at the University of Pittsburgh Magee Women's Hospital, where I was clinical director of some of the labs there. And we decided, based on talking to colleagues in the Department of Pathology and Neonatology, that our first assay would be to detect human parvovirus B19, which is a virus that if women who are pregnant catch that virus, it can have a severe impact on the developing fetus because the virus destroys your red cells, you get very anemic, fluid, your heart, all of that sort of stuff, and you become sort of hydroptic as a fetus. So we put this assay together, and the first week that this was live in the clinical lab as a test available, I get a call from the neonatologist who says, we have a pregnant woman coming in for an emergency C-section. She's 22 weeks gestation. Her fetus is severely hydroptic, and we want to be able to test for parvovirus. And it was like, oh my gosh, it was our first like clinical our first specimens to come in for this assay. So before the end of that same day, we had the result. It was a positive result for parvo. They were able to aggressively treat this little guy with packed red cells to get him over his anemia. He went home on his due date.
Wow.
And then years later, I get a card in the mail from his pediatrician saying, I want you to know that this little healthy guy just started kindergarten.
Wow. Yeah, that's huge.
I cried.
Yeah. Yeah.
So yeah,
Yeah.
so having an impact, it really drives you to do more.
So what's they're they're not competing, but there are two really interesting features to my mind of what you've described. One is, the kind of monumental patience it takes for each increment, right, in this process. So there's no kind of what I would call a big Hollywood moment, like you see in the movies when the scientist does something, it's like, oh, and now everything is perfect, right? No, so you have this monumental patience for each little moment to come to fruition or to be paid off. But then you do get, and thank goodness, you got this feedback from the pediatrician, right? Because
Right.
there really is a live
Yes.
result. of your work. And this one, as you call him, little guy, is just one of, you know, thousands at least, I would imagine, right? So that's incredibly powerful.
Yeah.
Yeah. So you get, I don't know, I guess you get more so your initial patients is the sort of, I would think, discipline that you developed in your training,
Hmm.
right? But then it's kind of fed, it's like almost like a feedback loop, but it's fed by the accomplishment, seeing what has happened as a result of all this patience, which feeds it even more.
I
Yeah.
think as a scientist, you really have to appreciate delayed gratification.
Mm, yeah. And is that something that you like when you are mentoring, or even just introducing people to at the level of sophistication where the students with whom you work are studying? Do they already have that? Do you have to reinforce that? And then the other bit of it is sort of the creativity. Like you work across disciplines in certain ways. Certainly, like you mentioned, GIS, for example, right? Or the scientist who's helping to develop the relevant, I don't know if it's programming or physical components of the essay that you ended up creating, right? So
Yeah.
you've got a lot of creativity, so you want to bolster that with your students, but at the same time, there's also this an incredible discipline that you have to have.
Yes. Uh, I think it, you have to believe in yourself
Hmm.
and know that as long as you're doing good quality work and asking relevant questions that will have an impact if things do work out, that's what you have to sort of commit yourself to and have other ways to fill up your soul if you're in sort of a downtime and things aren't working out. You can't beat yourself up, but it's sort of like mistakes are for learning, right?
Mm. Mhm.
Learn from what didn't go right so that you can change it so you can get it to go right, I guess.
Well, those words of wisdom are much appreciated and are a terrific place for us to end. Although, I would love to hear more from you. I could listen to you all day and ask more questions, and I hope I'll have the opportunity to interview you again. But thank you so much for taking time to chat with me today. I much appreciate your time and your
Oh,
expertise.
thank you, Mia. It was an honor and a pleasure and just a delight to be able to share these things with you.
Thank you. Thank you. Thanks again to Dr. Jeanne Jordan, Director of the International Institute for Public Health Laboratory Management and Emeritus Professor at George Washington University. Did you know that LabRoots is celebrating International Day of Women and Girls in Science on February 11th with a giveaway? We're giving away four $25 gift cards to the LabRoots Science Store, and entering is easy. Just check the episode description for the entry form and details. Be sure to enter by 5 p.m. Pacific time on February 11th. Meanwhile, a huge thanks to the women pushing STEM forward every day, women like Dr. Jeanne Jordan, and good luck to everyone who enters.